In this short video, I'm going to be talking with Paul from Tebis, and we're going to be talking about the automation of tooling libraries. Paul, there's many companies, most CAM companies offer something similar, but what makes your package different? Why is your tooling library different to the others?
Yeah, thanks, Joe. So firstly, we promote a cloud-based solution for our cutting tools and our libraries. Actually, we have 5 libraries. So cutting tools is our first one, virtual machines, our features, some standard machining cycles, and also process templates. But the cutting tools is one that kind of links into everything. It's one of the most important, if you like, and especially to set up. Now, what makes us different is the way we actually deal with all of the information and the data that goes within it. So to start with, we can organize our cutting tools into various different elements. So maybe a set of cutting tools per machine, that's in a machining cabinet, even, create special tools. But what we do is we break the tools down. So we're actually looking at, if you like, digital twins in the real world environment. And if we have a look at the screen, what we can see is what we promote is modeling all of your cutting tools themselves, the actual cutters, the tool holders, and the intermediate components as well, if we need the tool extensions. Now, what a lot of CAM systems do is that you get a tool length with a tool holder, and that's it. There's no idea about how this tool is going to be built up in reality. Tebis is very special at that because with these cutting tools, we actually manage the connections between, if you like, with a set of rules. So this reflects reality. So Tebis won't let you build a tool which is not able to be built in reality.
Okay. Even
to the extent of the back end of the tool holder is going to fit into a certain type of machine. We can control that too.
Well, how do we prevent, let's say we're a small company and you've got 2 or 3 seats of Tebis, how do you prevent, me using one control, you using another, and the tooling library being, if my library is different to yours, and we've got different machines, there's quite a lot to go wrong.
Okay, so yeah, with the cloud-based environment, what we have is a master tool library sitting on the cloud. This is the tool library that will be managed. And whenever somebody activates Tebis, they automatically get the download of the latest library. Okay, so everybody's going to be working off the same library structure. Nobody's going to be working differently because everything is synchronized in this manner. It's a lot easier to manage for large installations, and even small installations will get a benefit from it as well.
Okay, so that's the physical tool itself. But how about the data, maybe cutting data, maybe tool life? What happens if a tool wears, things like this?
Okay, yeah, so in the system, what we can do is we can manage a lot of parameters within the tool. The first thing I really like to show you first of all is the actual geometry of the tool, which is very important. Okay, so this is the first parameter that we actually get the most accurate tool geometry. And as you can see here, we have a cutting tool. You can see we have the core of the tool, and all of this is managed within the system. The system knows then where the core is, and this is a non-cutting edge. It could be the fact that maybe we have different types of tools, such as the large radius tools, such as barrel cutters. This is really important as well. The system has a highly efficient tool paths, which are able to adjust the tool path for barrel cutters, so you're going to get shorter machining times on large edges, and where it goes into radii, we'll see the tool paths tighten up. But because of this as well, we're going to be managing and actually simulating correctly the amount of residual stock material that's left in the part. And what a lot of systems do, they approximate. So you've actually got more material left on the component than actually what's there in reality.
Okay, so if we've got this tooling library, and obviously there's the automation element from the programming side, when we're picking surfaces, do we have to select the tool, or is the software able to say we recommend this tool?
So the software is actually able to select its own tool. You can pick it manually if you want to, but as far as automation goes, and this is what we're promoting, is that the system can actually pick the correct tool automatically for you. So if we use the feature technology, we have conditional statements, where the tool we can say, right, if this is the size hole we want to machine, the system will pick the correct size tool for that hole. It will even look at promoting, okay, in the library, which tool library do I want to use first? Which is the sequence that I have to look for the tools. And then within the tool itself, we have a lot of information, as you can see here. based on what cutting material we're going to use. The machining groups, the machining group, is it going to be a large machine we're using? Is it a small machine? Are we roughing or finishing? And all of these can be automated in the system and give you the correct machining parameters directly right from the start. So
that's important, is it? I presume there's default ones in there, but you can also work with your tooling supplier to put your own in, maybe?
Absolutely, yeah. You can import all of the data from the tooling supplier for geometry and also take all of their data as well. And what's important on here as well is that not just the feed rates, if you like, for rapid, for the cutting speed on the surface, but also things like corner feed rates, plunging, ramping, everything is stored in here, even step overs and depth of cut.
That's important, sorry, for like if you quoted a job, maybe you need a rough cycle time, it's going to be very accurate, isn't it? Whereas
absolutely,
quite often when we do these on other CAD, maybe it's not so.
Yeah, absolutely. So we actually do want a good cycle time for this, but probably what's even more important is standardization. Standardization, if I'm programming, if you're programming, we don't want to be doing things differently, because what companies want is a standard quality of part. We don't want variation every time we produce something. And by having these stored into the cutting data, we're going to be producing time and time again the same quality of component.
That's important, is it? You know, skills gap and all the rest of it. They all need skilled engineers, but you're taking reliance away from one human being. A lot of this data is stored in someone's brain, typically, isn't it? And you might need to go and see another programmer. Whereas now it's all stored on the cloud, stored across all the seats of Tebis you have. So, you know, the reliance is on the software rather than the human being. Absolutely, yeah.
But this actually allows us, it's not taking the skill away from programmers. Actually, we're promoting, upskilling other people, where we can bring people into your business, programming at the same level as people who have been there for a long time, in a very quick, short training period. Again, this is very important because, you know, companies that they want, with the skill shortages that are out there, that it's important to get the right people on and programming very quickly.
So how about the control of tools within the magazine itself?
Yeah, so actually in Tebis we're actually able to manage tool magazines within the system as well. Basically what we can do is we can set a set of magazines for particular machine types, even to the extent of mirroring the tool magazines of the first part. We can have a tool cabinet set of tools, even special tools. And the system can manage then, if you have a fixed location carousel on your machine or even a random carousel, to put the tools in the correct positions. Now all of this is possible because of all of the automation in the system and how it links in. But it's very important for managing the machines. And you can even mix and match. So you can have your tool magazine running on the machine for a lot of your standard tools, but the machine can automatically then move to a manual tool for something that's special, and the system defines all of this. And these again can be attached directly to a virtual machine that's in our libraries structure. So when you select a machine to program with, the tool set is automatically applied into this environment.
Very clever. I can see how, you know, the tooling library coupled with some of your other automation elements is going to be good. So how can engineers watching this video find out more about Tebis and tooling automation?
Yeah, so please contact us at the Tebis office. We'll be pleased to come and visit you on site, do a demonstration for you, have a look at how you're currently working and offer some advice on how we can help you in standardising your process.
Well, thank you, Paul. Thanks for your time, and
thank you.
Many thanks for watching at home.